Guys, Miss Alstrom here. I'm going to be doing the second part of PP 1.1 fundamental skills, and it's over factoring. Later on in quarter three, maybe carry over to quarter four, we're going to get into trigonometric functions. And so you have to be able to manipulate trig terms with trig identities in it. And one of the things that you have to be able to recognize is the ability to factor those. So we're going to move beyond just terms with variables and a coefficient, and we're going to have to simplify things with cosine, sine, tangent in it. But the properties underlying it is the same. Factoring a term, making sure that you have factors just means that there's multiplication between the two factors. Okay. And I'll talk about in class why that is useful in figuring out the variable. Okay. So one of the very first things that you see is the last terms of that expression. One's a negative, one's a positive. If the last term is a negative, if we eventually factor, it'll tell you that the second term of each of those factors, one's going to be a positive and one's going to be a negative. Okay, the two last terms are going to be different. Why? Because when we do FOIL, or first, outer, inner, and last is going to give you this final term in the end, this third term. And that when you multiply a positive and negative, you're always going to be getting a negative. Now, if the last term is positive, such as this one right here, either you're going to have both positives or both negatives. So the two last terms are the same. The second term, sine, will tell you what they are. So for this problem, we know that they're both going to be negatives. Why? Because when we do the O and the I, okay, and multiply that out, and we have the same terms for everything. So everything that you end up with FOIL, and you factor this, FOIL this out, you're going to have positive terms. So there is no way for you to get a negative for that middle term when you add the O and the I together. Same thing for here. If you do the first, it's going to be a positive, but the O and the I is going to involve that last term. So you're going to end up with a negative. You're going to be adding, and they're going to have the same sign. They're going to go in the same direction on the number line. Okay, and then this one, we know that it's positive, negative. So there's a couple of ways of factoring. So I'm going to write different and same, and then you look at the second term and it tells you they're both negative. There's a couple of methods in factoring. Some methods, it's better to know more than one method. There's a trial and error method where basically you create two parentheses, and then I know the only factors of 3 x squared could be 3x times x. Okay, and then I could list all the different factors of 56, 1, and 56, and 2, and there, I think 3, it's divisible by, is it 3? Let me see. And then we can list them, and then we could just trial and error um, the different ones, and then put it in, and then we could do the O and the I here. There's also the AC method, which is multiplying 3 times 56, and you get 168. And then figuring out, since they're going to be subtracted from each other, because we get the O and the I from here, okay, figuring out factors of 168, when you subtract them from each other, you get 13, that middle term, okay? This needs to be practiced, and whenever we have time to practice factoring trinomials, we will practice, okay? Let's see. So I wanted to teach you about the signs first, okay? Also, I wanted to see if these trinomials were factorable. So I talked about this in class. And so let's take, for example, 3x squared plus 13x minus 56. There might be a possibility that this trinomial may not be able to be factored into two binomials. It cannot be a factor of two binomials. And the way that you test that, you use the quadratic formula, part of the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. The quadratic formula also gives you x, okay? But if you look at right here, b squared minus 4ac is something called a discriminant. Discriminant. And discriminants discriminate. It's unfortunate they do, but they give us a kind of a key on whether or not that trinomial could be factored. Let's see, if b squared minus 4ac ends up becoming a negative, and that radical right there is very restrictive. If there's a radical with a negative inside of the radical, the radicand is negative, then you're going to have an imaginary. It's going to be an imaginary root. If it is a, let's see, anything that is not a perfect square, for example, square root of 2, and it simplifies as square root of 2, then it's going to be irrational. We have to take an estimate of what that's going to be when we plot that on the x-intercept. But if it's a perfect square, and what do I mean by perfect square? 0, well, 0 is special. It's only going to have one x-intercept. 1, 4, 9, 16, perfect squares. That means it's factorable. So I could quickly just look at it, and I could do the b squared minus 4ac. So I'm going to do 13 squared minus 4 times 3 times negative 56. And if I do the square root of 841, it's a perfect square. Okay, so I know that that trinomial is factorable. If I do the second one, b squared, we could put a parenthesis around that negative 47 squared minus 4ac 1369. I know again that that is factorable. Okay, so I think I'll be putting a link to how to factor from my previous old videos, so you can take a look at just simple factoring methods. There's also an AC method, so I'll put a link to that, but I'm gonna get into doing your practice. Okay, so the reason that I put, let's see, 1 through 9 are a special set of problems. Okay. The reason that I want you to see it, is to be able to for you to this the way that we do 1 through 9 has a lot of algebra skills in it. Okay. Now I asked in class, how many terms do you see in here? Now this is a trick question, and I'm sorry that I tricked some of you guys. But what you see in front of you is that 3 is multiplied by this factor right here. So 3 and x plus 5, which is one factor, like x plus 5 has to be contained. Theirs is as close as they get because they're inside of a parentheses. And there's multiplication outside of that, multiplying to 3. So you can consider that like one family. Okay? And then x plus 5 contained in a parentheses, that's one factor. Okay? And then x is being multiplied. So in fact, there is one term and two terms with an addition separating them. Okay, there's only two terms here, and it's a trick because you see 3 pluses. But what is outside of that is that it is contained in a parentheses and there is multiplication. So just like if we had an a squared plus a, and that's just a times a plus a. This is one term, this is two terms. I can actually take out an a from each of the terms, and when I'm taking the a out, I'm actually dividing the a times a divided by a plus a divided by a. That's factoring something out. It is the opposite of the distributive property of multiplication over addition. So that gives me a plus 1. Just like that, within the two terms, when you see a common factor, this is a common factor. X plus 5 is a common factor. I could take that x plus 5 out. Okay, after I take it out, remember, when you factor something out, it means you are dividing each of the terms by that factor. So when I factor that out, that simplifies, and what you have remaining is a 3 plus x. Now, if you want to put it as x plus 5, x plus 3, that's fine. You have just factorized because there are two factors contained inside of a parentheses with a multiplication operation in between. Here, 1, 2 factors. We can factor out b plus 3. Divide that by b plus 3. And why do I leave the parentheses in there outside in this denominator? For you to see. There we go. Simplify. A minus 5. Okay. Here we have an x times x plus 2, first factor, second factor, plus x plus 2 times x plus 5. First factor, second factor. What common factor do we have? X plus 2. Whoops. Once again, factoring something out is dividing that term by that factor. So I'm going to divide this by x plus 2. Divide that by x plus 2. Simplify, simplify. And I get x plus 5. I could have kept this in parentheses right here, but there's nothing outside of the parentheses but a plus 1. So I can actually take that out, and I can combine like terms. There's 1, 2x plus 5. There we go. Okay, good job. Next. Okay, I kind of want to fix it up later. Okay, next. This is a little different. First of all, I'm going to rewrite that factor as y plus 2. And remember, these are not equations. These are expressions. The difference between an expression and equation is an equation will have an equal sign and something else equal to it. This is just an expression. Okay, so just like the pattern above, I want this something here to make it look like one of the factors. So I notice that it's a y minus 2. It's a negative y minus 2. They're complete opposite signs than a plus y and a plus 2. So what I can do is I can factor out at negative 1 there. Oh, I don't want to do that. Okay. And I know this is strange, but this is the way that you have to be able to manipulate expressions and equations. I am not multiplying the entire thing by negative 1. I am just taking a section of it, this section right here, and I'm going to divide each of these by negative 1. And how does that negative 1 that I divided represent itself? I multiply it, and I put a parenthesis around it. And after I divide, I end up with a y plus 2. Now, if I distribute that negative 1 to the y and the plus 2, it ends up exactly like what we had above, and it gets rid of the parentheses. I'm just going to rewrite what I had as my first term. Okay, now I have two terms with a y plus 2 that is a factor that is common. So I'm going to take that y plus 2 and I'm going to divide both of these by y plus 2. So what do I have left over is a y minus 1. Again, we're going to do the same thing for number 5. Take this to try to make it look like x plus 2. So once again, I'm going to divide this by negative 1 and negative 1, and what it produces is an x plus 2, but don't forget that I factored out a negative 1, and if I redistribute, that becomes a negative x plus 2. Now I have two terms. I can factor out at x plus 2. The act of factoring out at x plus 2 is dividing each of these by x plus 2. So I get it a minus 1. Okay, now this is something different. It does look like the factor that's inside, x minus 3. Now, couldn't I just put a parenthesis by that and put 1 with an exponent of 1? Yeah, you can do that. Of course, there's just one of those. Okay, so I could actually take out 1x minus 3 because here we have two of those and this we have one of them. So that means I'm going to divide this by x minus 3, divide that by x minus 3, and I end up with well, it's a bracket, x minus 3, one of those, because there was two, and x minus 3 and x minus 3, that cancels out, so we have a plus 1. So I could take that bracket off, and now it's x minus 3 plus 1, x minus 3, x minus 2. Just simplify inside the parentheses. Okay, good job. Next, once again, I have this first term, and then I have two terms here, but I could combine those two terms and somehow make it into one term. And I could factor out a greatest common factor, which is 4. So that means I'm going to divide that by 4, divide that by 4. So I get a plus 4. I factor it out a plus 4. I get an x minus 2. And just one of those. So we have a 2, x minus 2 squared. Okay. Now I could look at these two terms. I've turned that three-term expression now into a two-term expression. And then I can say to myself, hey, I could take out x minus 2 from here. I could take out more, but I'm just going to keep it simple. I'm going to take out x minus 2. Okay, so when I take it out, it gets factored out. And what I have left over is a 2. 2 does not cancel out with x minus 2. X minus 2 in its entirety have to be canceled out. There was 2, and there's 1. So we have 1 x minus 2 left over. And here we have 1 and 1, so we have a plus 4. We need to clean this up inside the bracket. So we have x minus 2. Let's go ahead and distribute 2x minus 4 plus 4. So we end up with an x minus 2 times 2x. And that could be written as 2x times x minus 2. I got these problems from the NYP book. Okay, it does a little bit more than your average textbook. Okay, so let's take a look. Okay, and we have a multiplication between two factors. We have multiplication between two factors. And then we take a look. What's common between them is an x plus 2. Here we have an x plus 2. So that means I'm going to factor out an x plus 2. What do I have left over? I have an x left over and a plus. And you can leave it in the parentheses, but you'll soon discover you could just take the parentheses off because you just have a 1 in front of it. And so you have an x plus 2 times 2x plus 5. Just like that. Okay, good job. Okay, this one kind of looks like numbers 4 and 5. Remember, this is three terms. We have 1, 2, and 3. We need to make it into two terms. So what we're going to do is take these two and factor out a negative 1. Why? Because I want the sign of this negative in front of the x and the negative of the y to be both positive. So we have x plus y. And we just have one of those. And then we have an x plus y. We have 3 of them. Okay, and what am I going to factor out? I'm going to factor out an x plus y. Factor out an x plus y. One of them. So I end up with 2x plus, oh, let me go ahead and factor that out first. So what I end up with are 2 of those. And then a minus 1. Oh, this one's fun. Okay. Now, I have the option of actually taking that and foiling that and making it x plus y times x plus y, and then foiling it and adding 1 to it. It could be factored further, guys. This could be factored further, and this is the fun of it. This is the fun. Okay. Yeah, this is the fun part because this is a difference of squares. Yeah, this is a difference of squares. My answer key has something funny on it, but actually it could be factored further. You can actually factor this. Let's see. X plus y. Let me go ahead and do the FOIL on it. Is 2xy plus y squared. When I what I do with factoring perfect square trinomials, which is what that is I square the x, I square the y, square the x, and square the y. I multiply 1x and then 1y, which is 1xy, and then I double it. So that's times 2. So 2xy minus 1. Now that's what the answer key says. It actually works. Okay. What I recognize here is a difference of squares. So first of all, it's a difference with a minus. This is a perfect square. 1's a perfect square. So sidetrack. I could further factor this x plus y, which came from here. Okay. And then I could do x plus y plus 1 and x plus y minus 1. The x plus y could be contained in a small parentheses like that, but it's going to be released because it doesn't really need to be in a parentheses. But the alternate answer could be x plus y plus 1, and x plus y minus 1. If I try to take this and factor it, I could probably factor it in that manner. Well, no, you can factor this polynomial. But if you recognize it and put it together like that, then you could clearly see that you can factor that. Okay, so there's two answers to this. You can have either this, and for me, the yellow would be the actual complete factored form. Okay, now talking about difference of squares, we have 10, 11, 12. Those are difference of squares. And remember, difference of squares problems, basically the way you identify them is that, hey, first of all, there has to be a difference in between. It has to be a difference of two terms. And then you recognize, hey, that's a perfect square and that's a perfect square. And what do I mean by perfect square? It means it could be made up of two terms that are exactly the same as, or two factors that are exactly the same. 1 times 1. Okay. And the way that we do that, we can recognize that the middle term actually went away. It became a 0. So the O and the I, when we add them together, it has to equal 0, a FOIL. Okay. So let me go ahead and write the rest of it. The O and the I has to equal 0. So they have to be the same coefficient, but different signs, which tells us, and we could use the last term, pattern on it, and we can have a plus and a minus. And then how do we make the term exactly the same coefficient? Is you multiply it by the same thing. And the O and the I, the outer, is made up of multiplying these two terms together. And the inner is made up of multiplying those two terms together. So they have to be the exact same thing. So how do you make a product exactly the same? You make the factors exactly the same. So you have a 3x. Oh, this is not supposed to be x squared. It's just supposed to be x. 3x and a 3x and a 1 and 1. If I do the O and the I, the outer is going to be negative 3x. The inner is going to be positive 3x. Same coefficients, different signs. So that tells us that, hey, this is a difference of squares. There you go. Is this a difference of squares? Yes, it is. That's made up of 9x times 9x. 16y squared is made up of 4y times 4y. With a difference in between, the middle term is missing. The middle term should look something like xy, x times y, with just 1 for each of the x and y's. So I could go ahead, plus and minus, 9x, 9x, 4y, 4y. And once again, if I test it, if I do the outer, it's going to be negative. It's 9 times, I think it's 36 xy. And the inner is going to be positive 36 xy. So the middle term goes away. Okie dokie. So once again, two terms separated by a negative. Actually, I'm not going to put that down because there's a parentheses. I'm going to make them brackets. Okay, a bracket times a bracket. This is made up of a 3x minus 2 times a 3x minus 2. That's what it means there's two of them. 16 could be a 4 times 4. Okay, so plus 4 and a minus 4. The first term, we can have 3x minus 2 and a 3x minus 2. They have to be exactly the same. Do not change the sign. The only sign that changes is a sign of the last term in the factor. You can get rid of the parentheses, so it just becomes, or the bracket, plus 4, 3x minus 2 minus 4. That's a plus 2 minus 6. There we go. Good job, guys. Okay. These are just straight factoring. The first line. Okay. I don't like to factor with a coefficient of negative in the front. I'm going to factor out a -1 right here. So I end up with a 9x squared minus 6x plus 1. And I do every single step in my videos. And this is because I think people just take shortcuts without actually knowing what they're doing. And when you're factoring a -1 out, you are actually dividing each of the terms by a -1. It is the opposite of the distributive property of multiplication over addition. Okay, once again, I don't know how to factor, but I know that the last term is going to be the same. Last two terms are going to be the same, and this tells us that they are both negative. Negative and negative. This is a special kind of trinomial too. I already know it's 3x, 3x, and 1 and 1. It's because this product, the factors of 9 have to equal 6, so I know it's 3 and 3. And they have to be the same sign, so this already sets you up to be a negative and a negative. Okay, there's other ways for you to factor. You can practice that. There's going to be review videos on how to do the different kinds of factoring methods. Okay, so, and once again, whenever we have time, we're going to practice factoring. Okay, that's that. Okay, by the way, we have to always check to see number 14, like number 14, if there's a greatest common factor. Greatest common factor of this is 2. So I'm going to factor out a 2. So when I factor out a 2, it has to stay inside the expression. That's why you need that 2. Outside, pulled out. Okay, and then 8x plus, once again, here's my bad arithmetic coming into play. This is why on your test, you won't be able to use your graphing calculator, but you will be able to use a scientific calculator. Okay, plus 16. And then this sign tells you that they're the same. That sign tells you that they're both negative. X and X, negative and negative. 16 factors of 16 that equal 8. Okay, when you add them up. A second, is it 16? So we can do 16 divided by 2. Factors are 2 and 8. When they add them out together, do they equal 8? Nope. 16 divided by 4. 4 and 4. So 4 and 4. Okay. And or you can rewrite it as 2x minus 4 squared. That's another perfect square trinomial. Okay, perfect square trinomial, it just means that the factors are exactly the same. Difference of squares means that the coefficients are exactly the same except for the last term, the signs are different. Okay, let's try 15. Once again, I don't like a negative in front, and then I can also pull out a -3, I think. Okay, the way that I know that things are divisible by 3 is that I add up both of the uh, digits. 1 plus 8 is 9. That's divisible by 3. 9 is divisible by 3. 2 plus 7 is 9, which is divisible by 3. So I know that it's divisible by 3. Okay, so I get -3x squared plus, let me just make sure that I did this, minus plus, yeah. Sometimes I have a tendency to make mistakes. And then let's do 18. And the reason I do all of these in the calculator is because when I make videos, sometimes I have a tendency to make mistakes. I think that's a 9. And then it becomes a fairly easy factoring problem. Plus and plus, x and x, 3 and 3. What do you know? It's another perfect square trinomial, and you can write it in the expanded form with the x plus 3 separated out, or you can write it in the condensed form. Okay? Good job. Okay, next. Well, we do have a difference. And then we have x to the fourth and x to the second. Okay, but then we realize, hey, we could take some stuff out. We could take some we could take greatest common factors. So 48, 4 plus 8 is 12. 12, oops, 12. 12 is 1 plus 2, so that's 3. You can add the digits up again, and it'll tell you. Okay, so they're both divisible by 3. And also, there's 4 x's, and there's 2 x's, right here. So that's the common factor. It's 3x squared. So I have an x squared minus 48 divided by 3. So that's 16. Now that's a beautiful perfect square. Split the x's. One's a positive, one's a negative. Square root of 16, 4 and 4. Everything that you see has multiplication in between. That is completely factorized. Okay, good job. Number 17, what do we have in common? Okay, there's 6 m's, there's 2 m's, so I could take out 2 m's. There's 1 n, and there's 5 n's, so I can take out an n. And what do I have left over? I have 4 m's, no n's, and then no m's, and 4 n's. Okay, this right here is a difference of squares, because what is m made up of? M to the fourth is made up of m to the second times m to the second. N to the fourth is made up of n to the second times n to the second. And there is a subtraction in between. So that means it's m to the second n, what we factored out, difference of squares, plus and minus, m to the second, m to the second, n to the second, and n to the second. Okay, and then you see again right here, this one is really fun. You see right here, there's another difference of squares. This is made up of m times m. N to the second is made up of n times n, and there is a subtraction. What happened to that? There's a subtraction in the middle. Okay, so that means that it could be further factored out. M plus n minus n, m squared plus n squared, m squared n. Here is the completely factored form of that beautiful problem. So much fun. Okay. Next, fifth, fourth, and third. I think they're all divisible by 8. 48 divided by 8. I think that's 6. Okay, so 8w to the third. There's 5, 4, and 3. So we know that there's 3 in common. So 8w to the third, we factored out. Here, since there's 5, and we took 3 away, there's 2. And then when there's 1, and there's 6. 48 divided by 8 is 6. And there is just going to be, that's just going to be 1. And then we can factor this. This last sign tells us that these are going to be different. So I put a WW. I need factors of 6. When you subtract them from each other, you get a -1, that middle term, -1. And that's going to be 3. 3 has to go with the negative because you see the negative here. That's going to be the bigger factor. And 2. There we go. Good job, guys. Next. Okay, let's see if we could take anything out. First of all, I don't like this negative, so I'm going to take out a negative. Okay, there's 4 x's, there's 3 x's, and there's 2. So I need take out x to the second. X to the second, take out a negative x to the second. There is 1, 1, 1 y's, so I could take out a y. Okay, and then that leaves me with a -x² y. I factor that out, so I end up with a positive x to the second. Took care of the negative and the negative, that's a positive, and then 4 minus 2 is 2. Y's become 1. And it's a minus 6. We have 1 x left over. And a plus 5. And no x's and no y's left over. -x² y. This sign tells us that they're going to be the same. That middle sign tells us what they are. Negative and negative. X and x. Factors of 5. The only factor of 5 is 1 and 5. Eventually, when we do the O and the I, we add the -1 and the -5. We go -1 direction. We go 5 in the negative direction again. That's going to be -6 direction. That is your final answer. Good job, guys. Number 20. Okay, first, I can see that all of these could be divided by a 2. Okay, and then there's 4 C's, 3 C's, and 2 C's. So that means there's 2 C's in common. There's 2 D's, 2 D's, and 2 D's. That means there's 2 D's in common. So I'm going to factor all of that out. So I have a 2C2, D2 raised to the second power. And then once I finish factoring out, 2 and 2 cancel out. We end up with C to the second plus 14, 1C left over, plus 98 divided by 2 is 49. And there's 2 D's in the numerator, 2 D's in the denominator, 2 D's in the numerator, 2 D's in the denominator. So that's all that I could do. 2D2. Okay, sign tells us that they are common. The factor's second terms are common. That tells us what they are. C, C. Factors of 49, when you add them together, equal 14. That's going to be a 7 and a 7. That is a perfect square trinomial. C plus 7 squared. Good job. Next, number 21. Okay, so I'm going to use a different color. I don't know. I want like a pink. Okay. I don't want a negative. That's not pink. A light pink. Okay. Definitely take out a negative 3. 15 is divisible by 3. 1 plus 0 plus 8, that's 9. So negative 3. They have no a's in common whatsoever. Okay, because this one is a to the 0. There's no a's. Okay, and so I'm just going to take out a negative 1. So that gives me a negative 3. Remember, you have to write that in front of your parentheses. And then a to the 4th. This is tricky with the signs. That's a 5a minus 108 divided by 3, which is 36. So negative 3. That last term tells us that the signs are different. Oh, I forgot there's a to the second. A to the second, a to the second. Okay, that's how we split this up. A to the second times a to the second is a to the 4th. Let's see, factors of 36, when you subtract them from each other, you get 5. So 1 and 36, nope. 2 and 36 divided by 2, 18, nope. 3 and 13, nope. 36 divided by 4 doesn't work. Does 4 work? Yeah, 4 and 9. Yeah, that works. Now, where does the 9 go? In front of the, after the negative, 4 goes here. So when you take a look, okay, that's a good factor. That cannot be factored any further, but right here, this could be further factored because that's a difference of squares. That could be further factored. You can factor this as a plus 3 and a minus 3. A squared plus 4, negative 3, and there you go. Okay, good job, guys. Whoa, no! Shifted my entire board. Okay, I'm gonna go for a baby blue. Oh, baby blue. That's a pretty color. Okay, let's take a look at this one right here. This is a straightforward factoring problem. I think 12, 20, and 24 are all divisible by 4. Let's take a 4 out. I think that needs to be a little bit darker. Okay, take a 4 out. And so you end up with a 3n squared minus 5n minus 6. Okay. So I included a problem like this, and I think I showed this one in class, to remind you of the discriminant. Okay, so for example, let me find a problem. That was a trinomial. Like 21. And if I took the discriminant, okay, negative b squared, so b squared would be 15 squared minus 4 times, and I'm just going to take the straight negative 3 times 108. B squared minus 4ac, and I end up with a 1521. And I take 1521, and it's a perfect square. Okay, it's made up of 39 times 39. But if I take this one, and I can try it if I want to, okay? But you know that 6 doesn't have that many factors, and 3 doesn't have that many factors, and it's going to be where you subtract the two, find the difference of the two factors. So you can find the different combinations, or I'm just going to try b squared minus 4a C. And I get a 97. 97 is not factorable. This trinomial is not factorable into two binomials. So that is my final answer. Okay? Easy. Let's look at these three terms. What do they have in common? I definitely know that they have a 5 in common. 20 and 5 are both divisible. This is r to the fourth, r to the third, and r to the second. So r to the second. I have s to the 1, s to the 1, s to the 1. So I'm going to take an s to the 1 out. So I have a 5, r to the second, s to the 1. And I guarantee that on my tests and quizzes, all my variables are going to be x's and y's. If not, yeah, a's, yeah. I don't use different variables because it's hard for me to distinguish on your paper if it's a b or a 6 or an r and some kind of number. And so I end up with a 4 r to the second minus 4. That's right? 20 divided by 5 is 4. Okay, and an r plus 1. Everything simplifies on that last term. Okay, I already know that that's a difference of, not a difference, it's a perfect square trinomial. I've just been doing this for a long time. So, okay, so I have a minus and a minus. That sign tells us what they are. I mean, if they're same or different, they're the same. That tells us what they are. The factors of 4r squared is 4r times, 2r times 2r, and factors of 1 and 1. I mean, we could have tried 1 and, well, we could have tried the factor 1 and 4. Okay, trial and error. It's up to you. You can use the AC method. Okay, it's up to you. And so I know it's going to be a 2r1 and a 2r1. And I can check it. And I just know because the product of 4, whatever the factors of 4 are, they have to add up to be 4. So it's 2 and 2. And when you multiply that by 1, it's this, it's itself. So it's 2 and 2 still. You can write it this way or in the condensed form. Condensed form would be, doesn't matter. It's the same expression. Okay. Last one. We have 4 terms. Okay. And what I could do is I could group the two the way that it is, or I can move them around and then try to factor something out. So I'm going to group those two. Let me go ahead and write it. I'm going to make it a different color. And green. I'm going to group these two, and I'm going to group these two. Notice I'm grouping it with the signs too. Okay. And then I determine what's common between them. And it's a 5 and a 5. There's 5 x's here and 3 x's here, so that's going to be 3 x's. And over here, I'm going to take a 5 and a 5. So for the first two terms, when I take out a 5x cubed, I end up with an x squared minus 4. And for the second term, if I take out a plus 5, I end up with a x squared minus 4. This is exactly what you saw on these beginning problems. If you use the AC method, okay, and you realize that, hey, that's all I've been doing, good for you. Okay, what did they have in common is an x squared minus 4. I'm going to take that x squared minus 4 out. What do I have left over is a 5x cubed plus 5. Okay. I just realized that this is exactly what I did not want. Anyways, okay. I could see that over here, I could further take out a 5x cubed plus 1, and then you multiply that with x squared minus 4. So since it's multiplication between the parentheses and the 5, I could take the 5 out. X squared minus 4, x cubed plus 1. Now this is a difference of squares. So the way that it factors is x plus 2, x minus 2. This is a sum of cubes. You will not see a sum of cubes on any of my assessments or quizzes. For some reason, I put one on the homework because without even checking, okay? Because it's a formula, and I don't want you memorizing formulas. And most of you will just memorize formulas. And so the formula for sum of cubes is a cubed plus b cubed equals a plus b, and then a squared, different sign, ab, and then the same sign. Okay, so when I take x cubed plus 1, it is going to be x plus 1, square the first term, minus, multiply the two together, so that's going to be x, and then square the second term, which is going to be 1. Oh, put the whole thing. X plus 1, x squared minus x plus 1. There we go. That's it, guys. Good job.